Okay, here we go. What form is the first one in? What form is this? It's standard form. The ax squared plus bx plus c. That's standard form. If you don't have it filled in, by all means, fill it in standard form. This is part of your test. This is 1.1 and 1.2 right now, graphing the 3 different forms. I need to find the AOS, and so when it's in standard form, I use x equals negative b over 2a. Watch the negative in the formula. Some of you are making mistakes with that. There's the formula to find x, to find the AOS. And so I have negative, my b is 8, divided by 2 times a, which is negative 2. Negative 8 divided by negative 4 is positive 2. So I just found my axis of symmetry, and it is at x equals 2. So I go to my graph, I draw a dotted line, and I label it. This is how you label it, x equals 2. It's a vertical line. We took a test on linear functions. A vertical line is x equals a number. A horizontal line is y equals number. A line that has slanted slope is y equals mx plus b. That is the equation. I don't go off to the side and write x equals 2. I put it on the picture. There it is. What else is going to be x equals 2? What else will be x equals 2 in this picture? The vertex is going to land on this line somewheres. We just need to find out what that y value is. So I already know my vertex is going to be somewheres at 2 something. I just need to find out what y is. So I'm going to do f of 2. I've got my function, and I'm substituting in 2. So that would be negative 2 times my x, which is 2 squared, plus 8 times 2 plus 5. That comes from the original equation. I'm substituting in 2, and it's going to tell me what y equals. You need to follow PEMDAS, even when you're in calculus, pre-calculus, your whole life forever. There's an order. The universe has an order. My body has an order. If it wasn't, it would be chaos. Okay, order. So it says to do parentheses first, PEMDAS. I look at my parentheses, nothing to do. It's just a number. What comes after parentheses? Exponents. I do my exponent first. So that's negative 2 times 2 squared is 4. And I am going to simplify as I'm going right now to 16 plus 5. And then I just finish up that number crunching. Negative 8 plus 16 plus 5. So that's 8 plus 5 is 13. Okay, so my vertex is at 2, 13. Well, my graph doesn't go all the way up to 13. And so what I'm going to do is I'm going to say, this is 13. I'm going to find a place and say, that's where 13 is. I'm going to put my vertex at 2, 13. But that's not the only thing I need to do right now. I need to label the vertex. It's a point in space. That means I write down what that point is. That point is 2, 13. Now there's no mistaking whatsoever that that point is exactly at 2, 13. All right, I need to find the y-intercept. The y-intercept means that I let x equal 0. I let x equal 0 when I'm finding the y-intercept. Is it easy to find the y-intercept in standard form? Why? X is 0. This is 0. This is 0, which means it leaves just the 5 there. So I don't even have to do number crunching. 0 squared is 0 times negative 2 is 0. 8 times 0 is 0. So that's 0 plus 0 plus 5. So I don't have to do any number crunching in standard form. I'm going to say that this is 5 then. Make it as reasonable as I can. 5 isn't going to be right up near 13. So I do try to make it a little bit reasonable. I've labeled it as 5. And then I finish graphing this. How do I finish graphing? It's called the axis of symmetry because it shows symmetry. It's going to be a U shape. I can already see that it's coming up like this. The other half is going to be on the other side. So if this is 2 units away, then I can go 2 units away on the right and see exactly where the rest of that parabola goes. So if you looked at 1.1 or 1.2 graphing, some of you got a 50 or 60 only because you didn't label it. It's 3 parts. Axis of symmetry labeled, vertex labeled, graph. That's 3 parts. If you don't do 2 out of 3, that's 2/3 off. So if you have a low grade, you should just go back and label them. Resubmit it, email me, tell me, whatever, pass it in on homework. Okay? It's an easy fix, but you missed 2/3 of the problem. I can't give it to you. All right, so does this have a maximum or a minimum? It's the highest it goes. It has a maximum. And so what is that maximum point? 213. What about the domain of this function? What does domain stand for? X or Y? X. If I take my pencil and I run it along the x-axis, does the function exist over here? Remember, it's going out to infinity. It's going out. It's not going straight down. It's going out, 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 out. So that means that at this point, it would be there. So the domain is all the reals, but how do we write it? Going from negative infinity to positive infinity? Okay. The range is about the y value. So what's the range from least to greatest? Where does it start? Where does it go to? Is it everything? What do you got? So it goes from negative infinity because it goes all the way down and it stops at 13. Does it include 13? So it starts at negative infinity. We put a rounded bracket because it doesn't include it. How do you stop negative infinity and put your finger on it? You can't. But at 13, it does include that number. So we use the square bracket to show that it's included. That is standard form. What form is the next one in? This is vertex form. So that would be y equals a times x minus h squared plus k. That is vertex form. Now finding the AOS for vertex form is different. This is vertex form. So what might be the first thing I want to look for then? It's called vertex form. I should look for the vertex. So the vertex is at HK. It's at HK, not negative H. It's going to be the opposite of what H is, but it will be exactly what K is. So what is the vertex of this form? 2, -1. It will always be the opposite because of that negative sign that's in the formula. So it's 2, but then you take exactly what the K value is at -1. So the vertex is at 2, -1. So I go to 2, -1. I put my vertex and I label it as 2, -1. What would be the next easiest thing to find if I have the vertex? What do you got, Faith? The axis of symmetry, the AOS, goes through the vertex. So there's the vertex. Here is the line of symmetry that goes right through there. And I'm going to label it as x equals 2. Is the y-intercept easy to see in this one? Is it just -1? No. You have got to substitute in 0 and then simplify all of this. So I know the y-intercept includes 0. I need to do some number crunching on this. So looking at my equation, I have y equals 4 times 0 minus 2. There it is being substituted in. X is 0 squared minus 1. PEMDAS says starting with parentheses, 0 minus 2 is -2. I don't have to show every step. This is Honors Algebra 2 after all. But I'm saying that's when we're starting at -2. -2 squared is 4. So I have 4 times 4 minus 1. 16 minus 1 is 15. All right. So just because I have 0, 15 doesn't mean I have to use it. Yes, it asked me to find it, and I did. But as Moffat was talking about on the other graph, sometimes it's like, it's not exact. I would like to see a little bit more exactness on this right now. We pick the y-intercept because it would be very easy to graph and do it. But if you have a graph that doesn't have it on it, If you pick a point that's closer to the AOS, it's going to be there. So I could pick 1 and then use the symmetry of 1. It doesn't always have to be the y-intercept. We find the y-intercept because we always want to know where it's crossing the x and the y. That doesn't mean I have to use it in my graph. So this time, I'm actually going to look at, where are we? 1. And I could do that number crunching in my head. When x is 1, we put that on my graph to remind myself that that's where I'm working right now at 1. When x is 1, I get 1 minus 2 is -1. -1 squared is 1. 1 times 4 is 4, and 4 minus 1 is 3. When x is 1, I find that y is 3. So when x is 1, I could find 3. And again, if you label it as 15 on your y-axis, it's fine. You can do that. It's not going to be marked wrong because you've labeled it as being that. But I wanted to show you that you don't always have to use the y-intercept to graph. You can pick a number that's closer to the AOS, and it will be on the graph. And so I'm going to use my symmetry of being 1 unit away on the other side, and I can see that U shape now. And so I am going to sketch that graph. I've got my AOS, I've got my vertex, I'm done graphing. No points off. All right, so does this one have a maximum or a minimum? It's the lowest it will go. The lowest point makes it a minimum, and that minimum is at 2, -1. The domain is going out to infinity as it goes. So we know it's going from -infinity to +infinity. Least to greatest, you are always labeling that. And the range starts at 2, and yes, it includes 2. So I use a square bracket, and then it's going out to +infinity. And that was vertex form. One more form. What is the form of the third one? It's intercept form. The intercept form would be y equals a times x minus p times x minus q. X-intercepts are your p and q. How do I write intercepts? What are the intercepts? So 1, 0, 1, and it's a point at 1. So I would write it as a coordinate. It's a point. What's the second intercept? 5, 0 is the second one. 1, 2, 3, 1, 2, 3, 4, 5. And so because in the homework it says to label those things, I'm going to label that as 5, 0 and 1, 0. All right, here we go. So that is my intercepts. What would be the next thing I would want to find when I'm in intercept form? The AOS, because it's going to be halfway between your intercepts because of that symmetry. So to find the, oops, I wrote it in the wrong place, didn't I? I'm going to have to put arrows on this. Those are my intercepts. All right, so the AOS would be that we have x equals p plus q divided by 2. So that means we have 1 plus 5 divided by 2. And we get that x equals 3. I mean, I didn't really need to use a formula because they're whole numbers. I could have eyeballed it and said, okay, where is that middle place? Oh, right there. So again, I didn't have to do the number crunching, but I did because if anybody's trying to catch up and connect those points right now, I wanted to make sure I was fully doing this. Otherwise, I could have eyeballed it and seen exactly where that middle point was. Now I would find my vertex because I know my vertex lands exactly on the AOS. And so the vertex, I am looking for f of 3. When x is 3, what am I going to get? So I have 3 minus 1, 3 minus 5 from the original equation, just substituting in 3. I end up with 2 times -2. So my vertex will be at 3, -4. So at 3, -4, 1, 2, 3, 4. Label it as 3, -4. And I have enough information to draw the U shape. I don't need to look for the y-intercept to graph, but there might be a question here that says find the y-intercept. intercepts. I guess I would take that as the y-intercept as well. So when x is 0, what will I get for the y-intercept? You get -1 times -5. That'll be 5. 0, 5 is where the y-intercept is at. Y-intercept, x-intercepts. This has a minimum value of 3, -4. Domain is from -infinity to +infinity. The range starts at y is -4. So it starts at -4 and goes to +infinity. All right, so those are the 3 forms of graphing from 1.1 and 1.2. Now we need to talk about factoring and solving. So you're going to go to the very last page you have in your notes, wherever that is, blank page, and you're going to put down 1.1 through 1.4 test review. You're going to take some notes from hand. For this test review, I did put down that examples 1 through 3 was the quick check too, so that you would know that's part of your test. We just did examples 1 through 3, 3 forms of a quadratic. And then example 4. All right, so writing in standard form. What form is it in right now? It's an intercept form. So I need to multiply. They're all being multiplied. I'm going to start with multiplying the first 2 together first. Just -2 times x and -2 times 5. So I get -2x and -10. And I still have to keep it in parentheses because I have something else that needs to be multiplied. I don't use the -2 and multiply it to both parentheses. I only multiply it to 1. Now I'm just going to multiply again and use the FOIL method. First term, so I have -2x times x, which would be -2x squared. I'm not done with -2x. I still got to do -2x times -8, +16x, and I'm done with the -2x. Now I'm ready. So I did the distributive property twice is what I just did. Now I'm going to do the distributive property twice with -10. Keep your signs in front of your terms at all times. -10 times x is -10x. And then -10 times -8 is a +80. Now I just look for those 2 inner terms that are always going to be like terms to be able to combine together. I have x's here. So I have -2x squared. And then 16x minus 10x is 6x. And plus 80. Done. It's in standard form. I am trying to simplify, so PEMDAS still applies. Parentheses. Is there anything in the parentheses to be done? No. What comes after parentheses? Exponents. So I need to take care of the x minus 1 squared, and it is not x squared plus 1. If I asked you what 5 squared means, what does it mean? I don't want to know what the answer is. What does it mean to be 5 squared? It means 5 times 5. So if I have a parenthesis that's being squared, it would mean the same thing as well. I would have 4, and I'd have my 2 parentheses being multiplied with the plus 9. The parenthesis is being squared. So that means x minus 1 times x minus 1. And now we're back to where we were on the first example. All right, so I'm going to start with multiplying through with the 4. We get 4x minus 4, and that still has to be multiplied to the second parentheses. Go ahead and multiply 4x minus 4 and x minus 1. See what you get. With this, find the area of a rectangle that has a side of x and x plus 3. I'll let you copy down examples 6 and 7. What's the area of a rectangle? Just the regular formula, not looking at any of the algebra. What's the area of a rectangle? That's it. So area equals length times width. And I just substitute in every single thing they gave me. Did they give me area? Yes, it's 28. Length, I don't care which one you call length and width. I'm going to say that the length is x because I want it in front, and then x plus 3. All I need to do is simplify and solve. So I'll start with distributive property. X times x is x squared. X times 3 is 3x. And then you always want everything on the same side. So I'm going to shift the 28 to the right. If it's positive 28 on the left, what will it be on the right? Negative 28, because I'm subtracting 28 from both sides. All right. Now, when it comes to factoring, I let you continue to use your box method, star method, slide and divide method. I let you use those things, but I want to tell you right now that you're going to do a lot of factoring. You need to get used to just doing the guess and check method. I use the box method when it's one that I can't do. When I'm like, what the heck, I cannot get this problem. That's when I use those methods. I don't use those methods for an everyday process because it's very easy to factor with the guess and check method. My A up front is a 1. That's the easiest one. So I know it's just going to be x times x. What I need is factors of 28. They're going to add to 3. I got 1 and 28, 2 and 14, 4, 5. What would they say? 4 and 7, 4, 5, 6, 7. I'm back around on the other side. So I usually check my divisibility rules 1 through 10, and most of the time it makes me loop on the other side. So out of those factors of 28, which ones will add to 3? And when I say add, I mean adding integers. That means positive and negative numbers. 4 and 7. What do the signs on 4 and 7 have to be a positive 3? Negative 4 and positive 7 add to 3. Those are my factors then that go in here. Negative 4 and positive 7. Some of you were using the box and star method, and yet your factors weren't multiplying back to the original. You need to make sure you also check negative 4 times 7 is negative 28. Faith? No. Commutative property says that 2 times 3 is the same thing as 3 times 2. So these factors can be switched. Now I need to solve these. And so it says that I can take each factor and set it equal to 0 and solve them. Again, you wouldn't necessarily do this step. And go ahead and solve that. All right, so we get x equals 4 and x equals negative 7. Which answer is it going to be? Why 4? Can't have a negative side. So x equals 4 is the answer I'm going to use. I can't have a negative side. And it said find the area, so that would be 4 times 7. So the area would be 28. I want to practice factoring and help you guys use the guess and check. Guess and check is really easy, especially when A is prime and C is prime. I don't have any choices. When the numbers are prime, I don't have a lot of choices of what to put in there. What times what equals 2x squared? Exactly, 2x times x. That's all I have for that one. And what times what equals 1? 1 and 1. Now I just need to look at the signs need to be. I need to look at the inner and the outer to look at the middle term. The inner here, and I do this a lot as well, is 1x. Multiply it together so I can visually see it. And then 2x times 1 is 2x. Well, 1x plus 2x would be 3x. So it have to be less. It just says to factor. So I'm done factoring. Problem B, 6x squared minus 7x minus 3. I still am going to have my 2 sets of parentheses. 6 is not prime. So I have some options of what to put in for the 6, but 3 is prime. I only have 1 and 3 for factors of 3. And I have 2 sets of factors for 6. I have 1 and 6. And I also have 2 and 3. The more factors there are, that's the more guessing and checking you have to do. If the numbers are small, I use guess and check. But if the numbers are big, there's a lot of factors, that's when I would use the box method. All right, I know that 1 and 3 are going to go here because it's my only options. I'm going to use a pencil for the next one because I'm going to start with 1 and 6. So 1x and 6x. I need to check my middle term because I know x times 6 is 6x squared and 1 times 3 is 3. It's the middle term that I need to worry about. 1 times 6x is 6x. I'm just going to lightly write 6x. And then 1x times 3 is 3x. Will 6x and 3x add to the middle term of 7? No. So what I'm going to do is just erase the 6 and the 3. And I'm going to erase the 1 and 6. Before I get rid of 1 and 6, I need to switch them. And I need to put 6 here. And I need to put 1 here because that 3 is affecting our numbers. So I had 1 and 6. It didn't work. So I switched the 6 and 1. Now if I look at my inner term, I have 1 times 1x is 1. 6 times 3 is 18. And will 18 and 1 ever add to my middle term of 7? That means I'm done with the 1 and 6 completely. I chose that one because I knew that wasn't going to work. I wanted to show you how to do a guess and check. So now I'm going to put 2 and 3 in there. 2x and 3x. And then I look at those middle terms again. I have 1x times 3x is 3x. And 2 times 3 is 6. And again, 3 and 6 is not going to give me that 7. So what do? We have to switch them. Now I have 1 times 2x is 2x. 3 times 3 is 9. 9x and 2x will give me a negative 7x. What do the signs have to be on 2 and 9? Positive 2 and negative 9. So I know that my 9 came from here. 3x times negative 3 would give me negative 9. And then positive 1 times 2x would give me the 2x. I know it seems like a lot of work, but the more that we practice these, which we will be drilling on these, the better you will get at them. What do you always have to check before you just start factoring? Can you pull something out? Is there a common factor I can pull out from both of these? Higher, 4. I can pull a 4 out. And so 4x squared divided by 4 leaves 1x squared, or just x squared. And then negative 4 divided by 4 is negative 1. And you should visually check that with the distributive property to make sure you've done it correctly. 4 times x squared is 4x squared, and 4 times negative 1 is negative 4. What is this one called? It's called the blank of blank. The difference of squares. These are both squares. 1 squared is still 1. The difference of squares. It has no middle term. So I would have 4. In the homework, when you were using the box method or you were using the star method, you didn't have the 4 out front. Remember that when I multiply this all back together, it still has to equal the original. So many of you are missing the number out front. All right, so x times x is x squared, and 1 times 1 is 1. How do I get no middle term? Plus and minus. If I look at the middle term, inner, that would be 1x, and then outer would be a negative 1x. So I can have exactly the same thing in both parentheses, but have a plus and minus, and that's called the difference of squares. So there it is, fully factored. 4 times x plus 1 times x minus 1. Problem D, what's the very first thing I should do? What is the common factor I can pull out from all 3 terms? 4 is the highest. And so that leaves 8 divided by 4 is 2x squared, minus 20 divided by 4 is minus 5x, and then negative 12 divided by 4 is negative 3. So the only thing we're not going to be able to do today is solve the equation and find the zeros. That means the same thing. It means solve. Solve your factors. When you see the words solve in the homework, or you saw find the zeros, that means to solve the equation. If you look back at 1.4, let's finish this one. So I have 4, and then I have my 2 sets of parentheses. Factors of 2 are only 1 and 2. It's prime, that's good. 3 has 1 and 3. So we don't have very many options of how to get them in here. I'm going to start with x and 2x. And I'm going to lightly put 3 and 1, and then just check that middle term to see if everything works out. This is going to be 2x and 3x. And if I put minus minus to get a negative 5x, it's not going to multiply to a negative 3. That means I have to switch them and put 3 and 1. And now my inner term is negative is 6x. I don't know about the signs yet. 6x and 1x. So what do the signs have to be to get that negative 5? Negative 6, positive 1. Negative 6 and positive 1 add to 5, and then negative 3 times 1 does multiply to negative 3. You've got to check your last term as well. Megan, you need to check your middle term and last term when you're factoring. Yeah, it looked really good the first way we had it with negative 2 and negative 3, but it didn't multiply to that negative at the end.